both sides, and then use a double angle form, sum of the angle formula from trig to do it. But as my father used to say, that's too much sugar for a nickel. That's too much work. So what we're going to do is we're going to follow my steps. And that is take the derivative in place, right? So let's do it. The derivative of the left side, you'll find that you take the derivative of y squared so many times, you don't even have to think about it. It's 2y prime. Hadn't we already done it about 3 times? And it's equal to 2x. And then that's equal to, I'm going to write it and let you see if you agree with me. The derivative of the angle. Why don't you tell me, what's the derivative of the angle? She was setting us up, y'all. She was setting us up for what she was doing. She knew she wasn't going to have to work this thing, so she gave it to us to do what she did.
I love y'all that much.
I'm taking the derivative of the angle, so I'm going to take the first, isn't that a product? Is that right? So I'm going to take the first times the derivative of the second, plus the second times the derivative of the first. Do you agree? The product rule, I had to use the chain rule, didn't I? So I took the chain rule of the sine, which you know is the cosine. But then I had to take the derivative of the angle. But that's a product now, is it not? And the product rule. And then I had to do implicit differentiation within the product rule, huh? Okay? All right? But that doesn't change how we work it. That's another thing about my writings in blue, is I try to make it where they work all the time. And it does. So what did I say do next? Isolate y prime. Get y prime on one side by itself. So I think that I've got 2y prime. And then I'm going to have minus y because of that plus sign in front of the bracket, right? And then I'm going to have x y prime cosine x y is equal to, and now I have 2x plus y cosine x y. Do you agree? What I did is I multiplied this times this, and then I put it on the left-hand side. Would you agree that's what I did? That's certainly what I meant to do. Okay? And then I did this times this, and I left it alone. And that 2x was already there. And this 2y prime was already there. Everybody follow? But you know the next drill, don't you? And that is factor out the coefficients of y prime, right? So I'm going to do that. And that is, I've got 2y minus x cosine x y times y prime. And that's equal to 2x plus y I soft, why prime, don't it? And if you wanted something like the slope of the tangent line, you just substitute in that. So what do you notice about derivatives and implicit differentiation? How about they're ugly? There was an old song, I don't know the words to it, and I bet you've never heard of it, but I love the song, and that is, I beg your pardon, I didn't promise you a rose garden. We're just lucky to be able to take the derivative of it. So we're just gonna have to live with it being ugly. But we just take it for what it is, and you really ought to expect a pretty ugly answer with implicit differentiation. Any question on the process? I promise you, I've taught you everything I'm going to teach you new. All we're doing is just working a few more examples. That method, you just use over and over. Okay? Let's do another one.